Good afternoon. Welcome to the Public Sector Summit. My name is Nick. I'm your room host for the day. A couple of quick housekeeping tasks. Emergency exits are marked by those exit signs. The bathrooms are back through and across the hall past the escalators. Please silence all your phones and other electronic devices. And without further ado, I'd like to introduce Dr. Linda Hedges. That's going to tell us about optimizing AWS HPC workloads.
Thank you. Hello and welcome to the Public Sector Summit. Thanks for being at our talk today. Can you hear me? Okay.
No.
No. Okay. Today I'm going to talk about maximizing the HPC performance of your workloads with the latest AWS services. Can you hear me now? Yeah. Nice. My name's Linda Hedges. I'm an Amazon HPC applications engineer. I've been with Amazon doing HPC for about 4 years. Before that, I was doing computational fluid dynamics in the aerospace community. I've been running HPC workloads on AWS since about the time EC2 first came out. So needless to say, I'm a huge fan of HPC in the cloud. Today, I'm talking with Jay Demler. He is Senior Principal IT Architect at Raytheon. I've watched him navigate dealing with a wide number of internal customers with varying demands and successfully make them happy. So I feel very fortunate that he's here with us today to talk about some tidbits of what he does to make that happen. Here's the agenda for the talk. I'm going to talk about the items on the left, and Jay is going to talk about the items on the right. This is the latest services since reInvent. So the things I'm going to talk about today are the HPC services that were announced at reInvent. You may have seen HPC talk before at AWS, introduction, overview, best practices. This isn't one of those talks. This is simply talking about the services from reInvent, where I'm going to talk about which service was announced, why it's relevant to HPC, and then give you a chart on how to get started with it right now. If you like this format, let us know in the survey. So first, C5N was released for compute. This is a specifically targeted HPC instance. You can see the N there after C5. That stands for network. So with the N instance came 100 gigabits of bandwidth and also Elastic Fabric Adapter. Elastic Fabric Adapter is our latest network protocol. Also at reInvent, we announced a new storage capability perfect for HPC, Amazon FSx Lustre, which is a high-performance parallel file system. AWS ParalelCluster was announced. AWS ParalelCluster is a reincarnation of CFN Cluster, if you're familiar with that. And then finally, I'm going to talk about Session Manager, which is one of the tools in AWS Systems Manager. So AWS Systems Manager wasn't announced at reInvent, but Session Manager was. I think the most exciting aspect of reInvent in 2018 was that an HPC service was released in one of all the infrastructure categories for HPC. Putting these services together, we now have a complete supercomputer experience. Oh, first, why HPC on AWS? You can have it your way. You can pick the architecture that you want, the deployment that you want. You can go traditional, supercomputer-like, or you can go cloud native. If you have a large memory application, or maybe the on-premise cluster that you're using, there's someone there with a large memory application clogging up the cluster, boot them to the cloud, and you can get instances with terabytes of memory on it. Or the opposite. Perhaps you have a tightly coupled MPI application that doesn't require a lot of memory per compute node. Don't pay for memory if you don't need it. You can target the architecture that you want on AWS, whether it's the operating system. Many scientific applications run better with Ubuntu. You can use Ubuntu. The deployment method, you can deploy with Python or Ruby. You can have it the way you want on AWS. And we run lots of different workloads. So if you check out our HPC website, that's at the AWS website, you can go to the HPC pages. We have lots of use cases on the different types of HPC workloads that we run. But currently, we're running just about almost everything. You name it, we've got the workload running there, whether it's genomics or neurosciences, weather, climate, oil and gas, risk analysis, financial services, lots of computational fluid dynamics, thermal analysis, structural analysis. We have it running on AWS. If you need help getting going, make sure to contact us and we can help you get your workload running. At the core of almost every HPC application is compute. And the C5N is an exciting instance. Again, it was announced at reInvent last year. C5N is a version of the C5 instance, but with a network modification. So using the C5N.18x large, you can get 100 gigabits of bandwidth. The smaller instances, like the C5N.large, with one core, remember that a vCPU is half a core. It's one half of a hyper-threaded core. So if you see vCPU, divide that by 2 to get the number of cores. C5N.18x large has 36 cores. C5N.large has 1 core. But it also has 25 gigabits of bandwidth. This makes it a really nice instance for moving data around, perhaps for a master instance. C5N has a little more memory than C5 and also a little more memory bandwidth. It's also a Skylake instance, so if you have AVX 512 capability, you can optimize your application to run here. Oh. Most of all, though, C5N comes with Elastic Fabric adapter, which I will be talking about in a minute. The Elastic Fabric adapter is the device that lets you use the lowest latency network with the C5N instance. And all the N instance types that are being released will have access to EFA. Launching the C5N instance is quite like launching all the rest of the instances. You go to the master console, you click Launch an Instance, you pick the C5N.18x large instance here, and then it offers you the configuration panel. I'm sure you're more than familiar with this panel, but one thing that's unusual is that you're going to see Elastic Fabric adapters show up here. And if you want to use the device, click Enable, and that attaches the device to the C5N instance type. As you do that, you're going to see this blue box come up, and you're actually going to want to read this box. So this is going to tell you to add a security group to the outbound rule of the security group. I'm going to talk about that in a minute, but I really want to emphasize that this box is important because we're seeing this mistake happen a lot. If you set up EFA, it's not working, this box holds the key. And I'll talk about this 3 more times in the presentation. Another thing that's relatively new is you can specify the CPU options here. So by specifying the CPU options, you can turn on 1 thread per core, and this disables hyperthreading from the console. This is a really nice new capability for turning off hyperthreading. If you're going for the lowest latency connections, then launch your instance into a placement group. There's nothing new about that, but just a reminder to do so. I think Elastic Fabric Adapter is easily the most exciting service or capability that was announced at reInvent. It is the N on these instance types. Currently, you can get it with the C5N and the P3DN instance types. And by using the N instance with Elastic Fabric Adapter, you can get the lowest possible latency for your tightly coupled applications. We're seeing great results with AFA. If you're looking for a deep dive on how EFA works, I strongly recommend Brian Barrett's presentation from reInvent. So in order to access that, you can go to YouTube and search on Elastic Fabric Adapter, or you can go to the AWS HPC web pages, and you'll find a link to it there. It's a really great talk. Here's a kind of a quick cheat sheet on how EFA works. We have the stack here on the left, the without EFA stack, and then the with EFA stack over here. And you can see both use the same application. You don't need to modify your application to use EFA. It is just as it is, and it communicates through MPI. So without EFA, MPI then talks to the TCP/IP stack, which talks to the ENA network driver, which then talks to the ENA device. And it doesn't do this just once. It has to do it twice, once on the way to the physical network, and then once on the way back up. And that takes extra time. And so by using EFA, the application talks to MPI, and then through libfabric, it talks directly to the EFA device. And this is what gives you the latency savings by using EFA. With EFA, the different MPI implementations will support the version of libfabric that works with the EFA device. Currently, OpenMPI 3.1.3 and newer supports libfabric. Libfabric 1.8 will be the version that's released that supports EFA. Currently, to get libfabric 1.8, you need to go to the AWS website. I'll show you how to do that in just a second. But we're seeing some remarkable results with EFA. Oh, and I did want to mention that Intel and MPitch MPI should be releasing, hopefully later this summer, so that you can have access to EFA through those versions of MPI as well. So here's some results using EFA compared to not using it. You can see cores down here on the horizontal axis, and the scaling on the vertical axis. Perfect scaling is this red line right here. You want to be as close to that line, have as tall a curve as possible, and that demonstrates great scaling. This is an external aero computational fluid dynamics case using the flow solver CFD++, which was produced by Metacomp Technologies. Before, when we ran it, this is running without EFA using the TCP/IP stack, but we would tend to top out, for this particular case, around 400 cores. This is a smaller case, and so it's going to top out sooner than bigger cases. But what we find is without EFA, we can scale a case to about 50, 75,000 cells per core. But if you use EFA, you can see that the scaling is much better. In fact, this curve actually will turn around and go back up again. And so we're getting perhaps a factor of 4 or more better scaling by using EFA. There's 3 pieces of magic that come with the elastic fabric adapter. There is the greater bandwidth, which is more easily accessible with EFA. There's the lower latency, but there's also the SRD protocol. This is scalable, reliable datagram. And this is a proprietary AWS network protocol, which is working really good, really well to limit jitter. And what is remarkable about it is your calculation, your tightly coupled calculations are not going to march at the speed of the fastest network connection. They're going to march at the speed of the slowest network connection. So by using SRD, the applications work really well as the slowest network connection is actually quite fast. Okay, getting started with EFA. If you go to our website and search on getting started with EFA, you're going to pull up a tutorial, a cheat sheet on how to do it. It will walk you through these 7 steps here on how to set EFA up. It's really pretty simple to get going. Currently, EFA is supported already in launch templates. If you use launch templates, also with the run instance AWS CLI command, you can get access to EFA simply by adding this one command into the network interfaces section of the launch instances or the AWS CLI command. Okay, but step 1 is creating the EFA-enabled security group. Here's an example of the outbound rules of a security group, inbound rules, outbound rules, probably very familiar with this. You need a security group in both the inbound and the outbound rules. That's step 1. The tutorial will walk you through that. Most people look at step 1 and they're like, I know all about security groups. And they gloss over the fact that you have to modify the outbound security group. Now, that's unusual working on AWS. There's almost never a reason to modify the outbound security group. But here, it's vital. And I've seen this mistake made many times with days of effort lost. So double and triple check that you got the security group as you go to using EFA. The tutorial will walk you through the need to install the EFA software components. Soon enough, these will come already installed in our instances. But for now, you need to download the installer and run the installer. It just takes a few minutes. It can be done in user data if you need to. But make sure you check that out, and that will install the latest version of OpenMPI. It will install the driver, and it'll install libfabric to get you going. Almost as exciting at reInvent was the announcement for FSx Lustre, which is still pretty exciting. Many of you have used Lustre, which is an open source tool. It's very fiddly, it's difficult to manage, it's unreliable. With AWS, we manage it for you, and it is remarkably simple and remarkably reliable. It's a service to fall in love with. It's highly parallel, highly scalable. You can add it to all your compute instances, get 100 gigabits per second throughput, millions of IOPS, consistently low latencies. Very simple service to use. To use it, start by going to the console, pull up FSx Lustre, click on Create File System. One of the really nice things about FSx Lustre is it already syncs to an S3 bucket. So you can start with data in that bucket in S3. Here you select the bucket that you want to sync with, and then as you create the file system, that information is available to you on the volume. It's lazy loaded as you need it, so only the data that you actually end up using will be loaded into your volume. So this is just a really terrific feature. After you've selected your S3 bucket, you then click Attach. Clicking Attach doesn't actually attach it. What it does is it gives you a pop-up box here that tells you how to then go and attach it. So it gives you the commands that you need to get the file system attached. You can take these commands here for attaching your Lustre drive. You can put it into user data, and then you can have it automatically attached to your compute nodes as they come up. Finally, I do want to emphasize that with FSx Lustre, Lustre is right now the Linux version of FSx. Your data is not automatically copied back to S3. You'll need to do that, but there are CLI commands. Here's an example of one that lets you do this, and these are highly efficient commands. If you want, you can put it in as a cron job, or you can do it at the end of the run to make sure that your data gets copied back to the bucket of S3 that you're using. For orchestration, we have AWS ParalelCluster, which is the Swiss Army knives of cluster setups. It presents a traditional cluster experience. Pretty excited to be talking about it today, because today we announced a new version of ParalelCluster, which includes incorporation with Elastic Fabric Adapter. So if you want to get going quickly with Elastic Fabric Adapter, download the latest version of ParalelCluster. ParalelCluster is the new incarnation of CFN Cluster. It's open source, just like CFN Cluster is, but it is now a service. So if you're having troubles with it, you can file a ticket against it and get help for it. It comes with a variety of schedulers, Slurm, SunGrid Engine, and Torque, and incorporates into all the latest AWS services. Okay, so the architecture diagram for ParalelCluster is here. Again, it's remarkably similar to CFN Cluster, but there are some upgrades to the features. For example, the addition of FSx Lustre, EFA announced today, rated drives. You can have multiple NFS volumes attached. ParalelCluster is available in all of the standard regions, China, and in GovCloud. And so this is pretty remarkable to have it so widely available. I want to mention that one of the really nice features about ParalelCluster is that as you submit jobs to the scheduler, it will spin up compute nodes. As you've given it the limits to do so, it will then run those compute nodes. It will spin up compute nodes to run the jobs. It will then run the jobs through the compute nodes. When there's nothing left in the scheduler, it will turn off those compute nodes as necessary, so you're only ever using what you need. The new version of ParalelCluster has a real great scaling ability. You know, you launch a 50-node cluster into the queue, you get those compute nodes up very quickly. As soon as your job's done, they then spin back down again. Here is the documentation location for ParalelCluster. Also today, though, I believe was announced a new document location. So look for that announcement, and you'll find some documentation that is also on the AWS website. Installing ParalelCluster is easy. It installs to your client, the laptop or your desktop, using the PIP installer. You'll need Python and PIP on your desktop. I like installing it to Cloud9. Cloud9 is an AWS service. It's an IDE. You can launch a small Cloud9 T2.micro instance. You can install ParalelCluster directly to it. There's no need to install Python at that point. It's already there for you. And then you can use Cloud9 as you need to launch ParalelCluster. One of the really great features about Cloud9 is that when you're done using it, it works from a web browser. And when you're done using it, close out the web browser, and Cloud9 will stop the instance. Your data's still there. Next time you want to use it, go back to Cloud9. Takes a couple minutes. It'll start your instance back up, and you have quick access to ParalelCluster. Once ParalelCluster is installed, you then run pcluster configure. And this gives you a quick configuration text file. It's just a text file. You can edit it with any ASCII editor. There's a nice one on Cloud9. You can modify it for your tightly coupled workloads. Change out the instance type, set limits on your compute nodes, how many you want to have on there. There's about 2 weeks ago, there was a webinar put out by AWS on getting started with ParalelCluster. You can find a link to that also on YouTube or on our AWS website. Systems Manager was not announced at reInvent, but the new Session Manager tool was announced. Session Manager is really slick. I'll show you how to use it in just a second, but you can log on to your instances with just a couple quick clicks. The Xterm window shows up in the console, and there was no need for an SSH key. So in fact, you can have a completely private subnet for your compute nodes and rely on Session Manager and run command in order to get access to your compute nodes. So Session Manager lets you log on to your compute nodes, and run command lets you provision all of your compute nodes all at once. For example, maybe as you were setting up your installation, you forgot to install a library or a software package. You can go to Systems Manager, run command, and install that library, again, with just a few clicks. And another great thing about run command and Sessions Manager is that they're already in GovCloud. Authentication, therefore, doesn't happen through SSH or your SSH key. Authentication happens over IAM, which means that you can also monitor who's logging on to your instances and keep track of them through something like CloudTrail. Getting started with Session Manager, you go in through the console, look for AWS Session Manager. In the console, click on the left-hand side to get to Session Manager. You'll see a list of your instances here. Click on one, open it up, and you're going to get a terminal in your web browser. The actual terminal you get is much bigger. I've made it smaller here in order to be able to fit it onto the chart. Two things you have to do in order to access Session Manager. You need to make sure that your instance has a role that gives Session Manager permission to run on the instance. And then the second thing that you have to do is use the latest version of Amazon Machine Image, one of the more recent Quick Start machine images, or you need to install the SSM agent if you're using something that's not stock Amazon. And then you have immediate access to your instance, not through SSH. I do want to talk about performance considerations very briefly. This is the cheat sheet on how to get the best performance for running tightly coupled applications on AWS. You've probably seen a list like this before if you've seen any of our other videos. First, always use a real-world test case. And by that I mean not necessarily what you're modeling, but if you run large cases, check performance with a large case. AWS is only pay-as-you-go. There's no need to check a small case. If you test with a small case, you're probably not going to see the performance that's possible with AWS. So always check with the cases that you plan on using. We encourage our users to disable hyperthreading. I've showed a couple ways how to disable hyperthreading in this presentation. There are other ways as well. Disable hyperthreading and run on cores. You'll also want to bind the processes to the cores, so use processor affinity to the cores to get the very best performance out of your application. Also, launch into a placement group. Placement groups are easy and easy to forget. So if you want the best latency, best bandwidth, use a placement group. This is why I've got the chart up here. In past presentations, we've talked about the need to change the clock source for some applications. With the new Nitro instances, they're not using Zen anymore. There is no more need to change the clock source, and I encourage you to leave it with the default. So if you have been changing the clock source and you're running on a Nitro instance, C5 or M5, something like that, no more need to change the clock source. As ever, use an up-to-date operating system. CentOS 6.5 is not up to date, so I encourage you to use one of the more current operating systems to get the latest drivers and libraries. And finally, if you can take advantage of something like AVX 512, then compile for that, get the most out of your instance type. Well, thank you for listening to the presentation. I'm now going to turn it over to Jay Demler with Raytheon.
Good job, Linda. Okay. Is this one on now? Oh, I think I am. Well, thank you, Linda. For those of you who don't know her, either through the other presentations that she's done or other work that she's done through reInvent, Linda really is a great resource and deep knowledge in this, not just at AWS, but in the within the industry of itself. So as Dr. Hedges had said, my name is Jay Demler. I have a really long title at Raytheon that doesn't actually mean anything, but I am an IT architect, and I work out of our Dallas, Texas office, where I work in a division called Space and Airborne Systems. I wanted to come out and speak to you today about some work that Amazon and Raytheon had done together in order to solve problems, because that's what, as IT professionals, they ask us to do, day in and day out, is to solve a business problem, to get a new product out the door, to refine a business process, to make our customers happy, to increase our efficiency. So I'm going to talk a little bit more. Dr. Hedges, again, had done a great job of talking about the very specifics and nuts and bolts of using HPC and the new features and functionality that's coming out. And I just wanted to come up and kind of piggyback off that good work and talk about the work that we were doing at Raytheon and how more in a business context we're able to take these pieces, parts, and concepts and deliver value to our customers, which are, as you are all pretty well familiar with, the DoD, three-letter agencies, agencies like that. So let's get down to business. So getting to the data faster. One of the biggest concerns that we always have is making sure that our customers, may they be internal customers or external customers, are getting to the data faster. Why do we need to get them to the data faster? So that they can go on and do other work. Maybe the expected outcome was not what they had met, and they needed to rerun tests. But we want to make sure that they're being efficient. We want to make sure that we're doing as little time, freeing up as much machine time to share these very expensive rigs and HPC deployments that we can. So when we had asked Amazon to come in through their professional services and through their specialists to help us with our issues, we were running into the same things that many other corporations are. We would go out and spend quite a bit of money on an on-premise solution that we thought was pretty good. We would, have lots of meetings. We would have lots of, PMs and finance people in the room, and we'd come up with this great solution, and it never seemed that we could keep up. If we would order a 1,000-core system, then they would come and ask for 1,500 cores. If we would then go out and try to appease them and buy another 15-core system that, bigger and better and latest and greatest, maybe the new revolution of hardware, then they'd ask for 2,000 cores. And we saw this as this, very self-eating, self-defeating cycle that was going on. And we understood that, rather quickly that we could no longer do business as usual, which for us and for many of you in this room had always been to call your, favorite hardware company, work with your software vendors, put it together, put it in a data center, and then, set up your queues and set up your workloads. That wasn't going to cut it anymore, both from the expectation of our internal engineers and our internal developers, and it wasn't the expectation that we wanted to be setting with our customers out there in the field, because of the very important work that they needed to be doing. We needed to be, meeting those as well. So let's talk a little bit about how, we have the difference between the on-prem and the cloud solution, and what Raytheon really went through. We're going to refer to on-prem as just legacy, and whatever way that you're doing that. Maybe you're leasing some equipment from another provider. Maybe you've gone out and built your own. Maybe you bought a kit, or maybe you bought a set BOM that has come in from a vendor, and however you and your organization are doing that. And we'll refer to everything else really as just cloud. So with legacy, what are the issues that we're really experiencing? Well, to get to the data, you actually have to have a system available to you. With the cost of these items, some of these can extend into the multiple millions of dollars. As in most organizations, Raytheon has the process where when you have a dollar amount that continues to escalate, that's the continuing amount of signatures that needs to go up on, on top of that, and on top and top on top, getting to the point that eventually either the Pope or the, Sultan of Brunei or somebody has to sign off on this thing so you can actually, get it in the door. It takes multiple months. It is not uncommon for this to span multiple years. If you do not have it within the budgetary cycle of 1 year, this is not something that you usually can just go, in June of a year. It'd be great if we had an extra $3 million, so we'll see if we can find that. These are generally items that are going to be, requested within the budgetary cycle for the next year, and then maybe it'll go through multiple rounds, and maybe it'll get approved, maybe it won't. But we're seeing an average for decent-sized HPC systems to average time to between conception and then actually being able to purchase being about 18 months, and that right off the bat you're already losing that much time before you can even start to think about having some good results. Other problems you have? Multiple departments and handoffs between each of those. With your legacy or with your standard IT department setup, you're seeing tickets being created and then handed around. Maybe the network team receives a request, and then it goes to the facilities team to create space in your data center. Maybe that goes to the electrical team, and then they stand up power and create whips, and on and on and on. And you're seeing this handoff and this churn, and then the amount of time that it's sitting in queue after queue after queue. And just because of this handoff and the separation of these departments, as most large corporations and most large agencies have now, we're seeing an extended amount of time just to get the implementation done. And lastly, you are locked into whatever you've purchased. And while that is not always a bad idea, you have purchased this item or set of items, and then you have the ability to use it up any way that you want. You can run it 24 hours a day, you can run it part of the day. That isn't really what I'm trying to focus on here, is that when you have to live with whatever is purchased, and again, because this is multiple millions of dollars possibly, or many multiple years of software maintenance and warranty that you're purchasing, we tend to overanalyze, we tend to overthink, we try to get as near perfect as possible because we don't want to be the ones that has to go back into the finance committee and ask for more money or explain to some type of audit group why you're not getting any value out of the system because you're only utilizing 10% of it. So you attempt to make it as perfect as possible, and that may mean bringing in more experts, maybe you're bringing in more consultants, maybe you're having additional meetings, maybe additional PMs brought in, and the cycle just kind of perpetuates itself, and it goes on and on and on as you try to get as near perfect as possible. So what does cloud do for us in HPC, and what are we seeing that can eliminate these problems that we have? So one of the first things that we realized is that we could be up and running in weeks and not months. And I'm not saying that this as a theoretical exercise. I'm not saying this as like an academic exercise. Dr. Hedges, her partner Aaron, and a very small set of individuals from Raytheon were actually able to stand up a minimally viable product on HPC in under a month. Doing it as a professional services engagement, and not only was it up in under a month, this was the month between Thanksgiving and Christmas. So a very small team working very dedicated on this process. Now, was it perfect? No. But we could actually get to the data faster. We could get output for our customer by standing this up very quickly. We eliminated very many steps. We didn't go through procurement. We didn't have facilities to deal with. We didn't have to go through this queuing system. And speaking of that, instead of having multiple departments, handoffs to complete, and now my thing's broken. Yeah, it's broken. There's only 2 buttons on this, and I went to college a long time, so I think I can figure this out. Oh, good, now you gave me everything. All right. Instead of having these multitude of departments and handoffs and queues and tickets and things like that, we were able to accomplish this with a very small, concise team. When you eliminate the data center team, when you eliminate the networking team, and you're able to concentrate with a very small, dedicated group. Our group consisted of 2 specialists from Amazon, 1 professional service engineer, one programmer, 1 Linux admin, and me standing around looking like I knew what I was doing. So that consisted of our entire team. But having that very small team and sitting in one room and decisions being made across a table, we eliminated that churn. We eliminated that, let's hold another meeting. Let's bring in another let's bring in another perspective. Let's bring in another expert on this. And lastly, with the extreme flexibility of, with cloud, not buying into, these commitments and paying this as you, paying for the buy the drink model, we could be extremely flexible. We could experiment, we could scale up, we could scale down, we could see where there are, limitations within the design that we chose, and then we could attempt to go out and fix that. We didn't have to be perfect. We didn't even have to be 80%. You could just, go out and attempt to make it work. And if it failed, and it's failed spectacularly, well, that cost us a couple of bucks. Let's try again. So driving value with HPC, I think, is where really we were able to convince our management and our customer as this was very worthwhile for us to pursue. Kind of the nirvana of an IT role is when you can combine your technical expertise, but align that with the business values and the business needs. And I'm going to refer to that as driving value. With the legacy HPC solution, you were going to have some issues. Significant upfront costs, and however you were going to shake it out with these systems costing, upwards of $1 million. And for grins, I went out and I, quoted a 2,000 core system from a leading hardware vendor, and just the hardware alone, that cost today with hardware, for 2019 was well over, $2 million. That did not include software, that did not include data center, that did not include any type of licensing or consulting or anything else like that. So you see that significant upfront cost, and however your finance department or however your corporation is going to deal with it, either through a lease or through a amortization and depreciation over time, you are going to see a significant upfront cost that you are not going to see with HPC. 7 figures in hardware alone. The meter is always running, and this is something that we also saw in that when you are spending this much money, you're under significant pressure to get some type of value out of it. If someone is, giving you the ability and the funding to go out and build these types of systems, you have to show them some type of rate of return. And maybe you would be doing work that is sub-optimized for this type of system. And if you're not, you're scrounging around trying to find things to do with this equipment that you've spent all this money on. And I think lastly is that with legacy HPC solutions, you're seeing that as these solutions become more and more specialized, you might see a specialty hiring being taking place within your organization, that these individuals may only do one or two things. If your organization is not really well known for doing HPC, maybe you have an engineering function that needs it, but it's not your core competency, you may be hiring new staff that does one thing, and that you need to kind of fill out that role. And there's always that risk. With cloud-based HPC, you're looking again at, if I hit the wrong button, it doesn't work. No capital investments. Again, you're just paying for what you use. Moving to this OpEx model, significantly more flexible. I know a lot of corporations are moving to this OpEx model versus a CapEx model that we'd seen for many, many years. Turn off when not needed. We are seeing, especially in some of these programs that we run, that this high end where you're buying 2,000 cores or 5,000 cores for maybe a run that you do once a month, once a quarter. Maybe you do a demonstration for a customer and never need that capacity again. You can eliminate that issue because you can turn off when not needed, you can reduce when not needed, and you can right size that at any time. And then lastly, you create value in Nowt Albatross. Going back to that, finding work that's going to be specifically related to these very large purchases, you're not creating this burden both on your balance sheet and in your organization, and that dollars can be more wisely spent on other areas or other technologies or other investments that you could be making, and that is not sitting within a few racks in your data center, and you're just not getting as much value, as much of a business driver as you had hoped. And I think just to leave you with this slide is just, we're really pushing you to quit spending capital dollars on a single function infrastructure. When you have the flexibility of cloud and you have the ability to design and spin up and spin down, it gives you much more freedom, and you're not married to, or you're not being burdened by this set of very expensive hardware that may be only doing one thing. I always think it's funny when what else can we do with the HPC? HPC is not busy this month. What are we going to do with it? I'm like, we could send emails faster maybe. No one wants to cut paychecks faster. I mean, it's not like we can go out and go ahead and move that capacity over. With cloud, we can do that by just eliminating it. So if I leave you with anything today, the one thing that I'd like you to walk out of this room with is that HPC on cloud should increase your tolerance for risk. And that's a very powerful position to be in because, you've probably all asked yourself, well, if I had unlimited funds and unlimited times, think what I could accomplish. Now, you don't have that, but with cloud, it gives you the ability to make guesses, take risks, and go out and experiment more so than you ever would with multi-million-dollar equipment that will be sitting in your data center for 4, 5, 6 years to come. Seeing that you can deploy with HPC on cloud, you can deploy faster. And then as a low startup cost, freeing up those capital dollars to be moving elsewhere. So you have more time and more money. So what can you do? You can experiment more. You can rapidly try configurations not previously thought possible. Maybe you could swap in GPUs. Maybe you could change and see how your work functions on different processor types. This was never available on your on-prem solution. But maybe you would try turning hyperthreading off and on, and all that cost to you is just a few dollars by clock speed and clock hour that you're paying to AWS. It gives you that much more freedom, and it gives you that much more ability to grow your own skill set and to see what works for your organization. And lastly, you can take chances. And that is something that, for us to be able to take chances to experiment is not a gift that we get every day, right? We always have to do our work within the confines of our risk acceptance, within the ability to spend money or the ability to do time. This increases that exponentially, that you have a lot more flexibility with your money, you have a lot more flexibility with your time, and you have a lot more flexibility in trying different things that you would not normally be able to do. So I'm going to give you this charge, and even if it is an HPC that you do, maybe you just came in to find out about different services that we have. Whatever you want to do on the cloud, I'm going to send you as a charge out of this room, kind of with 3 things. One, if you're a child of the 80s and 90s, or if you had children from the 80s and the 90s, you may see this or may remember this from a children's book series called The Magic School Bus and their teacher, Miss Frizzle. And her line was, take chances, make mistakes, and get messy. And I think that was always a great takeaway from that, in that, as a child, we wanted to expand their minds. We wanted them to think, very broadly about the world and take chances, make mistakes, and get messy within reason. I mean, there were certain ideas that I came up with that my mother was never going to go for, usually involving gasoline and gunpowder and everything else. But let's just leave this one into cloud and HPC. But take chances. I still have a button problem. No long-term commitments. You are not being chained to this infrastructure. You're not being chained to the cost. You're not being chained to a contract or a warranty or a service contract or whatever we were, normally doing with our legacy infrastructure. Let that set you free, because you can get in and out, and you can scale up your commitment or scale down your commitment because it's only for the amount of time that you run. Make mistakes. I think that we always, especially when spending at this price point, and when we're always investing these types of dollars that we see at HPC in the hardware, we're so afraid to make mistakes that we almost have analysis paralysis. Oh, I can't do enough research. Oh, let me do one more test. Let me try talking to one more vendor. Let me get one more quote. Make mistakes. I think that's how we all learn, and the valuable lessons that we get out of it. I would love for each of you, your bosses, to walk into your office and say, hey, how did that work? And you go, failed spectacularly. It was awesome. And then you can all walk away from that, and it's not your job on the line. That you can learn from that, you can grow from that, and you can find out what works for your organization or your solution or your software package. And lastly, get messy. Dream and dream big. I think that, with the limitations and the shackles being thrown off from what we would normally see from a legacy purchase or a legacy installation, HPC, again, it just sets you free. If you want to try running a case at 1 million cores, Amazon can do that for you. If you want to try running, 4 separate instantiations of the same code in 4 different, configurations, you can do that. If you want to try breaking things, go right ahead. That's what it's there for. And that, again, sets you free. It makes you more valuable to your own career, and it makes you more valuable to your company and to your industry. So I guess this is the thank you slide. But we do have a couple of minutes left. But what I would like to do is, so I'm not standing up here by myself and staring into these very bright lights, I'd like to ask the HPC specialist from Amazon to come back up. And we have about 5 minutes left for questions. And I actually can't see anybody if you raise your hand, because it literally is blinding up here. So I'm going to oh, that's better.
My question about is parallel clustering and the session manager. That's the wonderful thing I think you guys added to the hypercomputing. My question is, how this one created is developed by Amazon or actually acquired from someone else? The question.
I'm sorry, I can't hear the question.
The question is this parallel cluster and session manager you presented. That 2 things is developed by Amazon itself or acquired from somewhere.
So the question was Parallel Cluster and Session Manager created by Amazon, or were they purchased from another third party and then integrated?
Well, Parallel Cluster was created by Amazon. It's the reincarnation of CFN Cluster, created by a couple SAs who were HPC specialists. I don't actually know the history of Session Manager. I imagine Amazon made it. What is also interesting, though, is that Session Manager integrates very easily into Parallel Cluster. So if you have a stand-up with Parallel Cluster, super easy to get Session Manager to help you to log on to your instance. Thank you.
Yes, sir. Oh,
So just curious, for that new instance, generally in the HPC environment, you recommend to running on multi-core process or the single-core process. I mean, another question is about the HPC, the whole stack, is that mostly optimized for the MPI only?
Oh no, it works great for high throughput computing runs as well. My specialty is the tightly coupled MPI-based applications. Lots of people, we ran, well, this one was also tightly coupled, but we ran to 28,000 instances on ParalelCluster. You could do that with the Monte Carlo methods and high throughput computing as well. It would work very well.
What kind of the language binding available at the moment?
Is what?
The language binding. I know MPI is one. Is there any other binding for the developers for the HPC environment? Is that any Java or Python or R or other language binding for
Lots are set up. And so if you want to come up afterwards, we can talk about what's of specific interest.
That's all right.
So this question is probably for Jay. So I have a lot of users doing HPC, and they make a lot of mistakes. So you said that you can launch a system with 1 million cores. What about if the people using that make mistakes? You still have to pay for that.
And you do. So yes, there is still a cost of mistakes, but you know, in the size of the organizations that we are, some of these mistakes may be a rounding error in a end of the year book. I think understanding what the limitations are, and that when having either less experienced staff or staff that you're trying to grow, taking the shackles completely off and say do whatever you want is not going to drive value in your organization, but understanding pairing them with individuals who have more experience or giving them caps on what they can actually spend would probably be a good idea. And I think that you should, when budgetary time comes around, you should have play money or sandbox money or whatever your organization calls it, and making sure that there is this time and expense that's allotted specifically for experimentation. Because if we were, it would be naive of us to walk in and say everything's going to run, fabulously the first time ever. So, we're going to cut this cost. We always should be providing some type of percentage overhead or something like that. But you are completely right. I say that get messy, but I'm not challenging all of you to see who racks up the biggest bill. I don't get reimbursed or anything from Amazon for that.
I don't want to monopolize this, so this will be for Linda. So I've been looking at the cost of using AWS or EC2 for HPC, and it still is, for regular computing, probably 5 to 6 times more expensive than on-premise. And I haven't looked at the CN5, so I don't know, it's probably even more expensive than what I was looking at. So could you give us an idea what the difference will be?
Well, we think we're very competitive, but comparing the cost of on-premise to in the cloud can be very difficult. And it can sometimes take a longer discussion, like an hour even, to talk about a true comparison. If you go to the AWS costing calculator, it's pretty easy to get a figure that looks pretty big. Oftentimes people are provisioning more storage, for example, than they really need in that way. So I would encourage you to come talk to us afterwards to get a bit more of an idea of how to dig into that, and we can help you do that.
Yeah. And one thing that I can add to that is that it's very difficult to do a comparison, and I spent quite a bit of time in the last year. There's a lot of sunk costs, there's a lot of hidden costs, there's a lot of costs that, for instance, IT costs may not be represented in data center. That may fall under your facilities bucket, or you may say, what's the value of this sysadmin and doing 10% of his, sysadmin work just for HPC. It gets, in speaking to a friend of mine who does a lot of consulting in this area, it's one of the things that he says is, Jay, that at the end of the day, it's almost more of an art than a science. But you can get close for finding out what your true number is, and the number for each of us is going to be different, however our IT departments are set up, or our budgets are set up. But it is extremely difficult to do and to nail down. what I've had success in is telling a good story for those people who are gatekeepers and purse holders at my organization, and talk about the soft dollar items versus the hard dollar items, and craft that story and say this is what's capable with cloud, and showing that, hey, with legacy, this is the upper limit we know that we can accomplish now. So that's a great question, but unfortunately, we wish we could whip out our iPhones and give you a number and say 42%, and it just unfortunately doesn't work like that.
So following up on the storage, when you are tiering from S3 to the cluster file system, and you want to do that for an entirely available public data set like Landsat data set, which is huge in petabyte scale. So how do you scale your Lustre file system, or do you skip Lustre altogether and use S3 directly in the cluster?
Well, anytime you can get to S3 directly, you're truly going cloud native, and you're going to save yourself money and time. Lustre works super well, and it will work for that application. And set up an ephemeral setup infrastructure, also cloud native, you can make it work very well. I would expect it to be a really great service for that. And we can talk to you afterwards about that, about getting going with it.
We are running large-scale multi-color simulation for financial industry on AWS Batch. Compared with AWS Batch, this parallel cluster was how long it take to launch 1,000 node.
How long does it take to do what?
How long it take to launch the cluster, the overall time to launch it. What's the mechanism? Like AWS Batch, we have Fargate, we have EKS, ECS, right? What's the behind the scenes, the backend of this parallel cluster? How long it take? I want to know how efficient the warm-up time.
Well, so first of all, Parallel Cluster and AWS Batch are very different services targeting pretty distinct applications and use cases. If you're using Parallel Cluster, you're really going for that supercomputer-like feel. If you're using AWS Batch or other HPC service, you're targeting really a cloud-native capability. The time it takes to launch a job itself on Parallel Cluster, it can be very quick. It has to do with how you set up the scheduler. And so that's unique to the person that is administrating the scheduler. If you use the defaults, though, I think that you're looking at, depending on the scale of your cluster, you're looking at 2 or 3 minutes to have a job go into the queue.
Probably what, one
Yeah.
more?
Want to do one more?
I think we can do one more,
Okay.
unless everyone just wants to go home early.
Last call for questions.
No. Oh, I got one more.
We are doing this high-performance computing using 3 kinds of computing service, ECS, Batch, and Lambda. So how can improve our experience with the new architecture, new product?
Well, AWS offers a lot of choice. And when I'm talking about HPC applications historically, HPC applications have not had a lot of choice. And so users are looking at different high-end infrastructure. But with AWS, you're not only looking at the infrastructure, but you can also look at the launching methods. And you can decide if you want to go cloud native. And this often, how cloud native you go depends on the staff that you have and what they're good at. So if you've got Java programmers, you might be looking at AWS Batch. If you have Fortran programmers, you're looking at Parallel Cluster. And so it really becomes up to your users and those who are doing the deployment work. I very much want to thank everybody for coming here. Please fill out the survey if you can find the app, which I can't. And thank you very much.
And as kind of parting for both Linda and I, we're always happy to answer questions. Either we're here tomorrow or after the talk now. You can get a hold of us. Linda's been kind enough to put her email address up there. Being in defense, I don't actually have an email address you can actually send me, but hey, my LinkedIn was up there, but not anymore. But please feel free to reach out. We're always willing to help. We're always willing to answer questions as best we can. Thank you, and have a great rest of your conference.